So I'm gonna start recording a little bit, and that way I can show you. So I've got this camera over here, so you can hopefully see this a little bit better. So this metal right here, these are strips of magnesium. Now, magnesium on the periodic table is a metal. And we've talked about metals. You know, we talked about metals, how they're shiny. They also say they're lustrous. But then there's these other two words that we had. One was ductile and the other was malleable. So it's malleable, you see, because I can bend it. So I could have a large piece of this magnesium and bend it into shape. And I can also stretch it and make wire out of it, or I can make this ribbon out of it, and that's what ductile is all about. And this does conduct heat and electricity. But what I want to do today is I want to burn it. So this is called a Bunsen burner, and a lot of you guys have probably seen one of these before. And so I basically turn on gas, the same gas that you guys have at home. It's a natural gas, they call it. It's methane is what the name is. This is a little sparker. It's like it's like a flint on a lighter. You know, when you turn the wheel, only the flint, see the flint's like right here. So it just scratches it on this thing inside. And as it scratches it, it sparks. Well, the sparks, then that's all we need. Then we light up our burner. I'm gonna go ahead and shut the lights off so you can see the burner a little bit better. So this is about the size that we want of a flame, about that much. And you might be able to see an inner blue cone. So you can see that different color in the middle. The very top of that is the hottest part of the flame. And that's where I'm gonna have to put this magnesium to get it to light on fire. So I'm gonna burn this. We're gonna do the old, go all Halloween on you here. That's super bright. See, Halloween, see, that's funny stuff. So that you wouldn't want to stare at that, you know. This is exactly what they put in fireworks. You know, the different colors in fireworks, they put different metals in there. This is the one that's always really the brightest one, magnesium. They grind it up and they put it in our fireworks. So let me turn, well, you can probably still see this because it looks like the camera adjusted. But look what's left here. So now I have this stuff. It's like, see, it's ash. It's not magnesium any longer. Okay? So that's what I want to do is I want to talk about that reaction that we just saw and see what that is. I'm going to rinse off my hands real quick. So I'm surprised that, yeah, this camera still works well, even though the lights aren't really up in here. Good aperture adjustment there. So let's think about this. So what that was magnesium. Mg. Not getting a very good focus on the camera. It's having a hard time, I think. Maybe if I put my hand over here or something, it'll focus a little bit better. No. Well, you can't see it. There. We'll do a little manual focus. Okay, so this is the chemical. So my question to you guys is, what did it burn in? It had to react with another element. What other element did it react with?
To fire, right?
Yeah, so it lit on fire. So that we know there was a chemical reaction that occurred. It wasn't physical, it was chemical. There was alterations. It's not magnesium anymore. It actually changed form. As you can see, now it was like this powdery stuff. So what mixed with the magnesium to make it and then light on fire like that? It had to be burning in something. some other element. How about the Bunsen burner? How about a lighter? How about your gas grill? All these different things that have methane, propane, butane. What do they burn in? How about a wood fire? Any fire you've seen, what element has to be around for the fire to burn?
Oh, oxygen.
Yes, oxygen, oxygen. Very good. Okay. So what happens is that the magnesium does eventually get oxidized by the oxygen. If I just let it sit outside, it would start to, we call it tarnish sometimes, like on silverware and stuff. It would react with the oxygen. But if I have heat present and I ignite that, it's called the energy of activation. They talk about it in biology sometimes too, a certain amount of energy. But as soon as I have it reach a certain temperature, kindling temperature, sometimes we call it that too, it ignites and it mixes with the oxygen and it burns. So this magnesium burned with oxygen. Now, oxygen is kind of interesting. It doesn't float around all by itself. So the oxygen that we breathe in the air is not just one little atom of oxygen. There's always two of them connected together. It's called diatomic. So whenever we have a chemical formula, oxygen will always have an O2. And that's the way it really is. All the oxygen on the planet are two oxygens connected together, okay? So this is our first time we've looked at a chemical equation, like a reaction that we have. So these are called reactants, and they react. So what was the powder? Well, the powder was called a product. It's what's made. So when we put these two together, we would make this. And that one chapter we did, we should be able to figure out what this is going to be. It's going to make magnesium oxide. You know, they end in IDE. So this should be magnesium oxide. Well, how do I know the ratio? How many Mg's for how many O's? You see, so when we did nomenclature, it was awesome because we got an opportunity to talk about things that are also going to be involved in other chapters that we do. We know what magnesium oxide is because we know how to look at the periodic table and say this is a +2 and this is a -2. And if the top is 0, then we're done, right? So that's what magnesium oxide is, MgO. Remember that if the charges were +2 and -1, we'd have to cross them and all that. So we could actually figure out what the product was, what that dust was. It was magnesium burning in oxygen, so it made magnesium oxide. All right. Well, now we talk about balancing. So what we're going to work on for a few days is balancing. And what balancing is that we have to put numbers in the front of here. And those numbers tell us the amount that we have of each one. So according to this equation right now, we have 1 magnesium, and then at the other side, there's 1 magnesium. That's balance. That's what balancing is. So we start out with 1 atom of magnesium, and you end with 1 magnesium. But you see, the oxygen doesn't make sense. There's 2 O's over here, but there's only 1 O over there. So that can't happen. You can't have anything just disappear, and you can't have anything just show up. Exactly the same amount of atoms that are on this side, called the reactants, have to equal the same amount of atoms that are over here on the products, what's produced, the products, they have to equal. Well, you can't just do this. This is what some people like. Well, then just put a 2 here. Now there's 2 O's and there's 2 O's. No. You can't do that because what we learned earlier in the year is this is not the formula of magnesium oxide. The formula of magnesium oxide is determined by these oxidation states that we know of, that we put on the periodic table at the top, how many electrons they want to gain and lose. So we can't alter this. We can't change the formula. So the only thing we can do is put numbers out here in the front, like that. That's called a coefficient. So now we would have 2 oxygens, because when I put a 2 here, that means I've got 2 of these. So I got an MgO and another MgO. So I've got 2 O's because I got double of that. And here I've got 1 of these. So now it's balanced. But what did I mess up? What did I mess up when I did that?
You didn't have two magnesium in the beginning?
Yeah, now my magnesium's not balanced because this says I have 1 magnesium, but then I made 2. They can't just, so it has to be equal, one side and the other. So we put a 2 here, and now it makes sense. And that's called a balanced reaction. So a balanced reaction would say, I start with 2 of these Mg's, and I end with 2 of these Mg's. I start with 2 oxygens, and I end with 2 oxygens. Okay? So I've got, obviously, now we're going to practice a little bit. And what we're going to do is we're going to put these numbers in the front called coefficients. And the goal is to balance the reaction. So learning the rules are pretty easy, but the puzzles are not so easy sometimes. So it's almost like, was that Sudoku or whatever, you know, something like that. Something where someone would say, hey, here's what you want to do. You want to make sure that you get, you know, here's the rules, 1 through 10 here in each box and all that. And then once you get the rules, then you got to solve the problem. So some balancing is easy and some of it gets kind of rough. So I mean, all I can do is basically tell you the rules of the game, but you're going to have to try to figure the puzzles out yourself. So let me, I'm going to flip this light back on so I can see a worksheet that I uploaded. Well, here, before I do that, I'm just gonna write out some examples, I think. All right, so here's some hydrogen. And hydrogen does the same exact thing that we just saw magnesium do. It also burns in oxygen. In fact, it was in the Hindenburg. You may have heard of this. It's a large blimp way back around World War I times, the Hindenburg, and it lit on fire and a bunch of people died. So we don't put hydrogen in our blimps anymore. What gas do you think is in the Goodyear blimp? What gas?
Helium.
Helium, good job, Taylor. See, helium is an inert gas, right? So if we look at this periodic table, these gases that we talked about in the other chapter, they're inert, they're non-reactive. So this is a great choice for the would have been a great choice for the Hindenburg, but they didn't put that in there. And that's what's in, you know, in the Goodyear blimp now. These don't react with anything, they're inert. But hydrogen does react, and it reacts with oxygen. And so if there's fire around, it will burn in the oxygen. And let's see what we're going to make. Well, these two are going to come together. So when H and O come together, is that what we get? I don't know. Here, let's check it out. Well, if I know that H is a +1 and I know O is a -2 by using the table, I cross these, I get this. We make water. So when hydrogen is lit on fire, like in the Hindenburg, they actually produced a bunch of water. Okay, so that's an equation. Now we have to balance it. And this is all we're going to work on. You're going to start with equations this week, and then I'm going to ask you to balance them, which means you're going to put numbers in the front of them. You can't change these little numbers. They're called subscripts because you would change the components. You would change the chemicals. You're only allowed to change how many of them you have by putting numbers in the front here called coefficients. So if you got 2 hydrogens on this side of this arrow, this is called the yield sign, and 2 over here, that's balanced. But you see how the O's aren't? So it's kind of like the problem we just ran into with the magnesium. So we put a 2 here, and then that would give me 2 O's. How many H's would I have on this side now?
4.
4. But you see, I only have 2 here. So I just come over and put a 2 right here. Now, when we don't put anything there, it's understood that it's a 1. When there's nothing there, it's a 1. So we would say, for grading purposes, because it makes it easier, because a lot of times there's eraser marks and stuff, we would say balanced one, we would say this is 2, 1, 2. Because it'd be like a 2, 1, 2. And then that would be a balanced equation. I'm going to draw out a picture of this real quick, just in case this helps you. So here's what an H2 looks like. They're bonded together. These are called covalent bonds. So there's 2 of these H2s that are together, 4 H's all together, plus 1 of these oxygens. Oxygen has a double bond. We haven't talked about any of that yet. And then that makes 2 waters. Here's what water looks like. You may have seen a picture of water somewhere in another book. So 1, 2, 3, 4 atoms of hydrogen on this side and 4 on this side, the products. We start with 2 atoms of oxygen over here, and we end with 2 atoms of oxygen. That's the goal. That's the rules. So the rules are, you got to make sure the atoms on the left side of the arrow equal the atoms on the right side, and you're only allowed to put numbers in the front, which are called coefficients. Let's check this one out. I'm looking for a better pen because my pen seems to be not working very well. So what we're seeing right here, this is a reaction that occurs inside of your vehicle, in your car. Where you burn gasoline, some of the carbon gets oxidized and it makes this stuff. Anybody know the name of that?
Carbon monoxide.
Good job, man. Carbon monoxide. So there's carbon dioxide and there's carbon monoxide. Carbon monoxide is dangerous. It's poisonous. In fact, we have carbon monoxide things in our houses sometimes because the furnace might also not burn carbon completely, and then we would get this. And then it messes with your hemoglobin. It blocks the sites, so oxygen can't get there, and then you fall asleep and you don't wake up. So did you notice that program used, he said carbon monoxide. He used the Greek system because see, C and O are both on this side of this line. And when they're both nonmetals, we use the Greek system, carbon monoxide. Okay, I'm just adding a bunch of stuff here. Let's get down to what the goal is for the next few days. This is not balanced. So you see there's a C and a C. So the C's are balanced. There's 2 O's and there's only 1 O. So I got to put a 2 here. So what happens is you go to balance one thing and now you messed up the other. So now we got to fix that. So then we put a 2 here. So now there's 2 C's, 2 C's, 2 O's, 2 O's. I'm gonna show you a couple more of these. Let me get one that's a little bit. Oh, let me do this one. This is something that you guys are familiar with. It's called hydrogen peroxide. Hydrogen peroxide. And when you pour that on a cut, it starts to fizz. It fizzes because it makes oxygen. And then the oxygen kills the bacteria and cleans out the cut. Okay, let's see. Two H's, two H's, two O's, 1, 2, 3 O's. See, the total number of O's over here have to equal the total over here, and they don't. So I guess I need more O's over here, but when I put that 2 there, so when I put a 2 here, and let me write the picture to make sure we understand, that means we'd have H2O2, H2O2. We put a 2 here, we have double of that. So now I've got 4 H's over here and 4 O's over here. And I only have 2 H's here. I'm going to put a 2 here. So I'm going to have 2 of these H2Os. So now I got 4 H's on this side. And I've got 2 O's. Oh, plus I got another 2 O's. I got an O2 over here. So I've got 1, 2, 3, 4 O's. So it's equal. So the answer would be 2, 2, 1 is the way we would say the answer is, like on worksheets and stuff, which we're going to get to in a little bit. Yeah, before we get to the worksheet, I made a little notes of, there's some things here that I wanted to tell you that just kind of come up that make things easier. Okay. What's not balanced in this one?
The O's.
Yeah. Now, Clifton, think about this. If I got 3 O's over here and 2 O's over here, what number do you think I'm going to have them to get them equal? How am I going to get a 2 and a 3 come out to be the same number?
Should be equal to 6.
It is equal to 6. That's called the least common multiple. So this is why I wanted to show you this example. When you got a 2 and a 3, the only way to get them equal is 6, because if you have 3 of these 2's, that'll be 6, and 2 3's, that'll be 6, and then they'll each equal 6. Sometimes you get like a 2 and a 5. Well, the 2 and a 5, the only way to get them equal is to make them equal to 10 each. So think about that thing called the least common multiple. That's why I'm showing you this example as that comes up. So if I put a 2 here, that gives me 6 O's, right? It gives me 2 K's, 2 CL's, and 6 O's. So I'm going to put a 3 here, and that'll give me 6 O's. And now I got my O's balanced. And then I can just go back and put, what number should I put here now?
2.
There you go. So that's the answer. 2, 2, 3. And that's a balanced equation. Let's do one with polyatomic ions in it. So we've dealt with these in the course now, these polyatomic ions. This one's called phosphate. We didn't have to actually memorize the names, but we would be able to figure out the name of this, like it's iron Roman numeral 2 phosphate. Well, there's a when you look at this, it will help if you can look at polyatomic ions instead of each one individually. Like you could say there's 1p, 4 O's, 8 O's. But if you group polyatomic ions together, it's like a shortcut that'll help. So this is like this is just Mr. Verbrugge's thing that I'm telling you, that I think it'll help, because I look at this as like 2 PO4s, and I see this as a PO4 over here. So I put a 2 here. Now, that way I take care of the oxygens and the phosphates, the P's at the same time. So least common multiples, that's one trick that I use. I think about that, and then I think about these polyatomic ions. And then after I do that, then I say, okay, look how many sodiums I got now. 6. So then I come over here and I put a 6 here. And then my chlorine, what number should I put here?
3.
Yeah, I got 3 Fe's, or you can look at it with the chlorines. Either way, I need a 3 here. Now, not everybody does them the same. It's like Sudoku or whatever it's called. You start at different places and you move around. There's no rules about where to start and where to end. So you'll see one person balance it completely different. Someone might have looked at this and they might have saw that there's 3 irons, and they might have put that 3 there, which gave them 6 of these, and they did that, and then they did this, and they went over here. See, I'm just showing you like how to get some answers, but there's multiple ways that you can get the answer. All you really need to know is you're allowed to put numbers in front of any of them, and you have to make this side equal to this side. That's the only rule really that you have to follow at the end. But you can jump all over the place if you want to. You do have to simplify though. So if you get to the end, like the answer to this one is 3, 2, 1, 6. 3, 2, 1, 6. If you get to the end and you get something like this, 2, 4, 2, 8. That's not the answer. This does happen. You see how you can divide all these by 2? So if you get something like that and you can divide them all by 2 or all by 3, you're supposed to simplify and make this 1, 2, 1, 4. So you should simplify. All right, let me show you the thing that's up on Canvas. So I have this up, and I have the key with it, which you're not supposed to look at right away, obviously. And then after that, I have a website that you go to. This is for tomorrow. So tomorrow, you know, is a day where you're not gonna have any Zooms in any classes tomorrow. And everybody's gonna give you something, which means you're gonna get a lot of work. That's typical. So I'm gonna give you an extra day, because I know that's gonna happen to you. So let's start this together, but I want you to check this out and the key. And then when you go to the website, you really can't miss them, because they say, oh, you did that wrong, try again, do this. They give you, it helps you. It's like an instructional balancing video. But let's do a couple of these. So what do you think we should do with this one?
Which one are you pointing to?
I'm sorry, no, number 1. Like, what's the problem? Like, is what's not balanced?
Oh, the bromine is not balanced?
It's not. So what should I do to balance it?
The right side had 2, so I think we should put 2 on the left side.
Right there. And we're not allowed to put a little number down there. The rules are you're only allowed to put numbers out front called coefficients. Okay. Now think about what did that change? Besides it now I have 2 BRs, but it messed up my Ks, right? So how about I go back over to the right and fix the Ks, which gives me 2 CLs, and I needed 2 CLs. So I'm done. I got 2 CLs on this side, 2 CLs on this side, 2 Ks, 2 Ks, 2 BRs, 2 BRs. So the answer is 1, 2, 1, 2. So this document is on Canvas for today with the key. So you're gonna have to pull this up when we get done and check it out. Look at number 2. Any idea on that one? How about no camera people? Some of the guys who don't have their cameras on. You guys got any ideas about what we should do on this one?
Put on number 3 or 2.
Number 2.
You put on the left side in CR, you put a 2.
Okay.
And then you put a 3. Oh, wait. Before you, wait. You put a 3 in front of the O2
So you're
on the
trying.
left side.
Yeah.
No, on the left.
You know what I liked about what you said is that and this is gonna happen to us. We see 2 CRs here. We might do this. We might find out later that we have to erase it. Okay,
Yeah.
that's wrong. Which you did. You already you figured that out. Because if I got 3 O's and 2 O's, what number are they going to have to equal?
6.
6. So you said put a 3 here and put a 2 here. So now I know that actually I should have put a 4 there.
Yeah.
Perfect. Good job. That's exactly what happens sometimes. You'll have a number, but you'll change another number and it'll mess up that number. Then you'll have to erase it. Probably better to use pencil a lot. Okay, let's look at number 3. So this one had the example I talked about earlier about the least common multiple. 2 O's, 3 O's. We made them both equal 6. What's this one got in it that might help us do it a little bit quicker?
Isn't it a polyatomic ion?
Does have a polyatomic ion in it. It's got this thing SO4, see? It's called sulfate. And there's 3 sulfates here. So if I put a 3 here, that gives me 3 SO4s. Now you do not have to do it this way. It's just an option that I found that makes me be able to go a little quicker instead of doing the S's and the O's separate. I'll do that sometimes, group polyatomic ions together. And then after you put a number, you think, okay, that balanced these out, but you look at what else it changed. Oh, it changed my H's. Now I have. So then you come over here and you put a 3, and now you have 6 H's. Now, things that are alone, like aluminum, you might as well always do them last because you can put any number in front of it, right? So this has 2 aluminum. There's another thing that I want to talk to you guys about before I let you try to balance some of these. I want to go down to number 10. This is an extremely important thing. When you're trying to figure out where to start, and you can start wherever you want, but when you're trying to do this, what you want to do is not start with elements that are in lots of things because you'll change them later. you'll be going to balance one thing and it'll change that. Like, see how oxygen is in this one and this one and this one and this one? You don't want to start by balancing your oxygens out, because when you go back to do your H's or your S's or your Cu's, you're going to end up messing them up anyway. So you want to start with things that are not in very many. Like coppers are only here and here, but they're already balanced. Hydrogens, only here and only here, but they're already balanced. Sulfurs. Okay. Sulfur would be a good place to start, not the oxygens, because basically there's 1, 2 sulfurs, but here there's only 1 sulfur. And then once I do this to get my sulfurs, I changed my H's, I changed my O's. Now, some people write down underneath them and try to keep track of everything, you know, like they'll write down, I got one of these, one of these, one of those. You know, that's a method that you could use if you wanted to. So I'm saying there's 1 Cu, 1 Cu, S's. Let's look at, I'm going to look at my H's now. I'm not going to look at my O's, because I need to get my H's set, and maybe my O's will come out. So I got 4 H's over here. So I need to put a 2 here, and then I'll have 4 H's. If my O's are balanced, I'm done. So I got, wow, this thing here has 8 O's, because there's 2 of these. This is 4 plus 2 plus 2, 8. That's it. So the answer is 1, 2, 1, 1, 2. Let me recap a few things here. The rules are get this side equal to that side and put numbers in front. That's it. That's the only rules. But when you're solving a puzzle, as you know, it's good to know a few things, a few tips that might help. One tip is think about least common multiples. Another tip is think about polyatomic ions. And the other tip is start with things that aren't in a lot of them, okay? Like you don't want to start with something that's in a bunch of different chemicals, because you'll end up changing it later anyway when you do that. Now, we're all at different places. Some people have done a lot of balancing. I know they have. Some people have done very little of it. It was like years ago, like in 8th grade. So some people are going to pick this up quicker. But the reason I've given you the program is it's for the beginner. The program you're going to go to from the link on Canvas is for a beginner person who has not balanced before. And they walk you through stuff and kind of help you, show you pictures and diagrams and give you hints and things. It's going to take you a while to go through that. So it would be longer than, well, it might be 1 class period like tomorrow, but it might be a little longer than that. So that's why, and I know you're going to get a lot of stuff tomorrow. So I'm going to give you all the way until Friday to do that, to get that assignment done. So what you do is you go to the website and so you're going to get a document. Let me show you this. Make sure that we're clear. So this is the practice that we're looking at right now. So you should do this and then look at the key there. So that's the thing that we're looking at currently, which I've got up here on Canvas. But it says, use this link below and do the assignment on Canvas. So this is the assignment. So in assignments, when you open it, there's actually a worksheet that's there. And the worksheet is the exact same things that are online. So after you balance this, let's just balance this one. This would be 1, 1, 1. And then see how they show you the little picture below here? 1 Fe, 1 Fe, 1 S, 1 S. And then you say, okay, balanced. And then it tells you some extra information there. And then it goes on to the next one. Well, the worksheet has these same things down. So you put the answers on the worksheet, and that's how I know that you went through the program. And then you upload that. You upload the assignment and have all the answers on it that are there. So, see. Yeah, I think I had a copy of that here. Let me show you that. See, these are the directions that you have, and then you go there, and then you basically do what we just did. So here you put 1, 1, 1. And then the next problem is this one, H2Cl2. Well, that's the next problem that's on the program here. See, H2Cl2. So you see the worksheet goes along with it. So you fill in the worksheet as you do the program. It's basically impossible not to get 100 on this. So all you got to do is go through the program and do it. But I wanted to make sure, I don't know where we're all at on this. And it's going to be really easy for some of you, but I can't take that for granted. I don't know where everybody's at on balancing equations. So you finish that up and turn it in by midnight Thursday night. That would be awesome-into. Okay.